Okay, we're going to take 15 minutes to better understand web development technologies from an entrepreneurial standpoint. So let's dive right in. Let's start at the development of the internet, particularly with the TCP protocol, the being able to use phone lines for machines to talk. We wanted a decentralized phone system, essentially, because we were worried that a nuclear attack would start by targeting telecommunications backbones. And so we wanted a decentralized system that could automatically reroute traffic so you wouldn't notice if, one of our central lines were cut. And so we built as ARPA, the predecessor to DARPA, the Defense Research Project. So we uh, we built a network to essentially work around the Ruskies. But that was TCP/IP. That was the fundamental network. Email was one of the first things that was built on top of that, but it wasn't until much later when Tim Berners-Lee at CERN developed the HTTP, Hypertext Transfer Protocol. From that, we were able to use a set of URLs to transmit displays and graphical layouts over this network. So thanks to this guy right here, we have the internet as we know it. The ARPANET gave us TCP/IP. Tim Berners-Lee gave us HTTP that goes over that network. Are there more complications to networks? Yes. There is a vastly more complex complexity within the OSI layers. Um, if you want to keep on researching it, that's fine, but we're going to need to draw acceptable lines of abstraction somewhere, and that is the one, network now understood. HTML is the language that is transmitted through this HTTP protocol. It can be, it doesn't have to be, but that's how all web browsers display. It's a very flexible markup language. It's not a programming language. I mean, of there is some debate about that, but essentially, no, it doesn't do some of the core constructs of what a programming language does. It doesn't loop, it doesn't have if statements. There is no application logic. It's a display language, and it has a buddy too. CSS doesn't exist on its own. CSS is the Robin to HTML's Batman. It just defines styles that can target elements over in the DOM, over in this document object model. So in this hierarchy of elements, CSS can make an effect on that. It wasn't until Netscape brought us JavaScript. No relation to Java in actuality. JavaScript is slowly taking over the world. But it was something neat because it allowed us to make little animations. That was the Netscape globe. How it kind of animated that little GIF and all that kind of nonsense. Those little animations, that stuff was brought to us in part by JavaScript. Okay, I want you to do something for me real quick. If you've got Google Chrome or Firefox, open it up. If you don't have that, download and install it. You are going to do your first programming because you're going to right click or two finger tap and go to inspect. And then we're going to hop right into the console right here. And this talks in JavaScript. So you can do something cool. Let's do console.log hello. And there goes. It printed hello. You are now a programmer. Congratulations. You've done your first line of JavaScript. More and more, this browser of ours is turning into a JavaScript engine because all of our apps are starting to run on JavaScript. In fact, Slack is run on JavaScript, and now you're downloading and installing little JavaScript windows. So JavaScript is now crawling out of our browser and onto all of our other apps. It's craziness. Okay, this is simplifying things again a little bit, but so the picture I've painted so far as for languages are concerned, we've had web languages over here that are meant primarily for display, and then programming languages. Programming languages that have the core construct of how one thinks. Conditions, if this, then that, loops and repetition, storage and retrieval of data. the basic operations or core constructs of programming languages. That's what this language is over here, and they're roughly categorized into generations. And some of the things that make a third generation, just to give you an example, is dynamic typing for one. So in Java, a second generation programming language, widely used everywhere, Java, well, this is how you make a comment, so I'm very easily distracted on these topics. If I wanted to make a variable, a container called X, and it held a number, I need to declare to Java exactly what type of variable this is. It is an integer. It contains this type of thing, a number, no decimal, from within a certain range. And so 5 is now stored in this variable. With Python, you don't need to do that. You create a variable, you tell it 5, and then you can take the same variable and put a word inside, a string, and it will just dynamically it'll just redefine itself and saying, oh no, I contain a string now. And so flexibility in programming is just one attribute. The implications from this are vast, but I just wanted to draw some distinction between that. Python and Ruby, side note, are cousin languages. They both were spawned from a very large project management tool. When they developed something called Basecamp, these languages spun out of that. Very similar, though. The more you look at them, the more you realize that they behave quite differently. And now, the thing that I need to make clear before I get distracted by relative strengths and weaknesses between the languages, JavaScript is no longer in here. JavaScript is free from the notion of being just a markup language. And there's other markup languages like markup. There is actually a little shortcut called markup as well. Anyway, JavaScript is now sort of in the middle. We should note that JavaScript, much like Python, when it executes, when it's compiled down, the way it runs it all comes down to C. In the end, the language, among all of our languages that we talk about, you'll get C because that's what's run fast. That's application logic specifically tailored to your processor. Java, for example, has to run a virtual machine that translates in real time, and as such, it's very portable. But its restriction is that it has to run that interpretation through a virtual machine that's running on top of your computer. C, when it's compiled, it transcribes it once so it runs on your computer's architecture, and then it can run lightning fast. And so that's why the most high performance games and other software run on C. Even if you're programming it in Python or JavaScript, when it executes on your computer, it's executing in C because that's fast. So we've got high performance JavaScript able to run on your browser. We've got Node. Node is a new JavaScript library that allows JavaScript to run independently. That's Slack is running on Node. It's actually another library on top of Node called Electron that allows JavaScript to have like a Windows form and have a structure of an app like we're used to it. So that's Electron. And that's still JavaScript. It's just layers of JavaScript that have given us that. It runs very fast, it's very nice, but it is a bit of a system hog because it has these large dependencies. In order to run Spotify, Slack, all of these things, it has to run a lot of JavaScript layers. Okay, so now let's get into the very controversial topic of ranking languages and comparing them on what should I build my app on. I was told this. Math is math. I don't know if someone famous said this when trying to compare languages, but math is math. And so as long as the execution of something isn't slow, for example, with certain programming languages, there have been notorious types of data processing that go slower on one system over another until a version release comes out and suddenly optimizes that thing, and so that slowdown no longer happens. So as long as execution goes quickly, it doesn't matter. Now you might have to think, okay, assuming that the application does it work with how I want to display the information. Okay, that's key. You want to make sure that that is interconnectivity between your logic and your display is smooth, and so that is important. And the maintenance and growth of that language. You want to make sure that if you invest in developing in a certain language, that you can continue that growth. For example, it would be a very bad idea to develop your app in Pascal or Fortran or an older language. Not only is it hard to get that to a display and slower, but it'll be harder to find people that can work on that if you wanted to add new features. So Python, Ruby, Go, Google's new language, depending on there are different advantages and strengths between them. However, for the most part, it doesn't really matter for basic application logic. Math is math. But what I'm going to talk about soon is as because JavaScript is now taking over the way we render our front end, the fact that we can now build JavaScript on our back end using frameworks like Express and Node, all based on Node. Because we can do that, having JavaScript on the back end as well as the front end means that developers can sort of move back and forth between them. You can get a more diverse set of team, whatever. So anyway, there's people just like saying, "Oh, it's Java way, all JavaScript from the top all the way to the back." It's charts like this that drive the conversation. Whereas that the longer your page takes to load, the less conversion, the fewer customers you'll get. So it's the asynchronous nature of JavaScript that is so advantageous because it can fill in pieces as it goes. Rather than waiting for the complete picture, you can have this sort of fill in what you've got, go, rapid display on your front end. Now to bring it full circle, now we'll have these JavaScript libraries that build our own HTML and CSS. That's still the core display. And so, but they'll build dynamic, more complex elements that it would be actually a kind of big pain to code by hand. And they send, and it updates without ever having to reload the page. You don't have to click a link and then wait for it to all go again. It just works as if it's an app running on your computer. In fact, sometimes it is. And so, what this is doing in the background is it sends over to the backend to your web server, your API. It will send a request, the same sort of HTTP request like you plugging into a web browser. It will send that information. But our server, instead of responding with a whole HTML package, it will just respond with a little JSON file, a little JavaScript object notation, a little packet of information that our JavaScript can then render and add into the mix. And so that's why you can just scroll down on Facebook and it'll just keep loading information as you go, because it'll send in background API requests and fill in the picture without you having to reload the page. And that's why we build decoupled front ends to talk to a back end server. Next time, I will talk about why microservices are complicated.